We're now 12 days from the eclipse on April 8th, when for a few minutes in the afternoon over northwestern Pennsylvania, the moon will totally block the sun, and more than 90% of the sun in the rest of the state. Of course, whether you can actually see the eclipse depends on the weather. Now here's the path through North America, a total eclipse within that approximately 100-mile wide swath from northern Mexico to northern New England, partial eclipse on either side. Now let's bring in the weather side of things. Here's the path of totality overlaid on the average percent of cloud cover between noon and 4 p.m. in the first half of April, based on more than 40 years of data. The northwest half of Pennsylvania is 70 to 80%. The southeast half, 60 to 70%. Not exactly encouraging. The best chance of seeing the total eclipse based on this history is in Texas. A fair question now that we're within 2 weeks is whether we can tweak this climatology map using the long-range computer model guidance. Well, let me start by showing that this far out, individual models tend to be inconsistent with their forecasts. Here's a cloud cover forecast valid at 2 p.m. Eastern Time on April 8th, about when the eclipse starts here. The green shades, especially the deeper green, mean cloudy skies, while the browns would suggest relatively clear skies. This is from the American model and was made this past Sunday afternoon, so it was a 15-day forecast. Now here's the model forecast made 12 hours later, that is the 14.5-day forecast for the eclipse. More green in the state, indicating poor viewing. And now here's the 14-day forecast, the 13.5-day forecast, the 13-day forecast, and finally the forecast made earlier today. Did you notice how the locations of the greens and browns kept shifting from image to image? This far out, individual model forecasts for a given event, in this case the eclipse, are very inconsistent from one model run to the next. So these forecasts aren't that useful. And that's why this far out we turn to ensemble forecasting, like what we use on week 2 trends, where a model is run multiple times with slightly different starting values, producing a set or ensemble of forecasts. And from that set you can compute probabilities. As an example, here's a forecast generated from a set of 135 recent model runs. This is the probability of less than 50% cloud cover, basically no worse than partly cloudy, for the afternoon of April 8th. About half of Pennsylvania is in the 20 to 30% chance of partly cloudy or better skies. The other half, 30 to 40% chance, which is not that far from climatology. And in fact, this ensemble-based cloud forecast for the entire lower 48 doesn't look all that different from the historical average. So in summary, here we are 12 days out. I think climatology is probably still the best forecast, but we will continue to refine this outlook, starting with week 2 trends on Friday. Stay tuned. Our extended forecast is next.